So now let's get started with coding the pothole detector using YOLO V5. So let's look at the complete set of processes which we will do. So we'll first download the YOLO model files and then we will also prepare the annotated files. Now in a previous post about on RCNN or earlier, we used the annotated file in a specific format, because we if you remember in post 2 we prepared the annotated files using img label img, and then we saved all the annotations into a CSV file, and that's what we used in the on all the previous posts. Now for YOLO there is a specific requirement in terms of how the annotations have to be. So we will prepare those annotated files, and then we'll prepare, after that we'll prepare the train validation and test sets. Then we will get into the implementation of the training process, and then also the inference process. So these are the steps which we will carry out in this video. So as usual, let's import all the necessary packages. Now the YOLO file or all the scripts which are required for training a YOLO model from scratch is contained in a GitHub, and this is the GitHub where you have all those things. So once you import this, so you can clone the Git library using this command. And just a note here, now this implementation we will be doing both in the Jupyter notebook and also in scripts. Now even though we are implementing many of these commands in the Jupyter notebook, all these folders which you see would be created in your local machine, and then you'll have to first create a folder specifically for this project. So I've created a project called BQ YOLO V5, and that's where this notebook resides. So I'll be toggling between the screen, the scripts and the Jupyter notebook. Now the scripts which you see and all these folder structures which you see are in my PyCharm ID. You can use any ID for that matter, or you can even use the ordinary terminal. So it doesn't matter where you actually use it. You can use a spider, you can use PyCharm, and whichever ID you want, or you can just do it in a native folder also. So I'll be toggling between the PyCharm screen and the Jupyter notebook on and off, so that things becomes clear. So most of the implementation we'll do it on the Jupyter notebook, and then we'll see what effect it has on the PyCharm screen. So that's the way we'll go about it. So once you clone this specific this folder from this, I've already done this, so I'm not cloning it again. But once you do it, what will happen is you'll see in the folder a new file called new folder called YOLO V5. So this is a new folder which will get created once the necessary folders or all the scripts are downloaded from the GitHub. So it will have its own other sets of folders. We'll come to that, but once you implement this, you will see this specific folder, and this is a main folder which will be used for implementing or training and the inference for our pothole detector using YOLO V5. So that's the download steps. Let's get back to the Jupyter notebook. So next we will look into our annotated file, or the CSV file where all the annotation information was saved. So this is I'm just reading the annotated file. So this is the annotated file. So as you can see, you have the file name and other annotation information, the width, height, and the bounding box information along with the class. So that's that's how our annotation file looks like. So what we'll do first is we'll extract the classes from this file, so we will do it by taking the unique of all the classes which are there and making it into a list. And so we have, as you know, we have 4 different classes. Now we'll come to it why we are doing this, because we need to make kind of another file called the YAML file later, wherein all these class information are included there. So that's why we'll be extracting this. We'll see to it. So here, so in the next step, what we'll do is we'll create a dictionary. This is called a class map dictionary. So here, this is a mapping between the pothole name or the class names, different class names which we have, and into an integer. So that's what we are doing here. So we first create a empty dictionary, and then we iterate through the different classes here. So and each of the class name is annotated or saved as a separate integer here. So you have 1 to 3. Since we have 4 classes, we have 0 to 3 integers which represents the classes. So the next step is to create a lot of folders, different folders which are required for the whole process. So let's first make a main data folder, a folder called the pothole data. So this is one, and inside the pothole data folder, we create 2 different folders called the images and the labels. So now images are where all the train, test, and validation images are kept, and the labels are where all the labels are kept. And as I said earlier, for YOLO 5, these labels, the annotations are kept in a separate format called the text files. So all these labels are kept as a text files along with the images. We'll come to that later. We'll come to the process of how do we create those text files, and we will see one of those text files also. So that's a requirement for doing a training in YOLO 5. And then we'll also make other folders, like you have to create within the images, you have to create a train, validation, and test set. And similarly for labels also, we have to create train, validation, and test sets. So once we implement this, I'm not running this because I've already created this. So once we implement this, you will see a folder called pothole data created, and these labels or these folders, specific folders, images and labels. And under images, you will find 3 different folders: test, train, and validation. And similarly, you will find it for labels. So just ignore these text files for now, because we will come to that step. But basically, you should find these 3 different folders which are created, which should be created by now for you. Let's get back to the Jupyter notebook now. Next is the process of taking these information in the annotation file, and creating these text files for these annotations. So what we do is we first take a list of all the images. So here, as you know, the images are in the specific column called the file name. So these are the specific images which we have. So and we are taking the unique of these images, because the same image is repeated many times, and this is because you would have different multiple classes within that image. So a image will have more than one potholes and more than one vegetation, etc. That's why it is repeating. So we will take all those images, unique images, all those unique images which we do, and then we first start with an iteration through those images. So we'll create an empty list called the bounding details, and this is where we are going to capture all those bounding box information. And here what we are doing is we are looking at we are taking all those information for that specific image. you know. So here we are saying that file name is equal to image. So we are taking all those information. So ideally we'll get a set of information pertaining to a particular image like this. You know, you will have a a set of information which will be in a pandas data frame format, and then we will iterate through each of those information which we have extracted so far. So so first what we will do is, first we'll extract the class ID, the ID of the class. So here we know that the class is the pothole or the vegetation or whatever it is. So first we will extract the class ID. So in row class, what we get is we get the class name, you know, like the pothole and vegetation, and then we use that map. So we have created all these maps here, right? So from the map, when we give the class name, you get a class ID. So either 0 or 1. So for example, for pothole you'll get as 1, and vegetation, no, pothole you'll get it as 0, and vegetation as 1, etc. So here we are going to get the class ID. Then next is to extract all this bounding box information. So in our earlier all our implementations, our bounding box information was in the form of xmax, xmin, etc. But for YOLO it's a different thing. So here, as we have seen earlier, we need the information, the bounding box or the coordinates of the center. So that's a bx and by. So that the center of coordinates are required, and also the width and the height. So that's how. So these steps are to create those coordinates from the information which we have. So the width would be the row maximum minus the row the minimum. So x max minus the x min would be the width, and the y max minus the y min would be the height. So we'll extract these information, and the center information would be the x min plus the x max divided by 2. So that's the x coordinate for the center, and the y coordinate for the center would be the y min plus y max divided by 2. So that's those are the center coordinates which we require. And then we're going to normalize that by dividing it by the width and the height. So the x we have normalizing by dividing by the width, and y we are normalizing by dividing by the height. So all these information, the center, both the center x and y, and the width and the height are captured or extracted, and then these are appended to our the empty list which we created. So we are appending that. So we first we get the class ID, then the center x, center y, bounding box width, and bounding box height. So it will run through the loop, extract all those all the information, both and looking and for all those images, and then finally what we are doing is we are writing that into a text file. So this we just done a print statement. So once you do this or once you run this loop, you will create a lot of text files would get created in this. So we'll see the contents of the text file next.